Hello guys, in this video I'm going to introduce you to Lightning Thunder. Thunder is a new project which really makes running PyTorch models faster on a lightning speed. Primarily, Thunder is a source-to-source compiler for PyTorch. It enables PyTorch programs faster by combining and using different hardware executors at once. And those executors are NVFuser, Torch.compiler, CUDNN, and Transformer Engine FP8. Let me give you a very quick overview of all of these. And as usual, almost most of these um, hardware executors are from NVIDIA. For instance, NVFuser is a tool by NVIDIA for optimizing deep learning models by fusing multiple operations into a single kernel, which enhances performance on GPUs. Whereas torch.compile, it is a feature in PyTorch enabling the compilation of Torch scripts modules for improved performance and deployment. Whereas this CUDNN, this is NVIDIA's CUDA's deep neural network library, and it offers highly optimized primitives and functions for accelerating deep learning tasks on CUDA compatible GPUs. And then we have this Transformer Engine FP8. This is a variant of the transformer model architecture using mixed precision training with 8-bit floating point numbers, balancing performance and precision in natural language processing tasks. Now, whether you are using single accelerator or you are using multiple ones, this works perfectly well in all of these. And also, if you look at the performance of this is also really good. So this um, benchmark uh, is by using Llama 7 billion on H100 GPU card with one batch, and you can see that through the compounding effect of these optimization of this Thunder and the use of best-in-class executor, the performance has increased a lot. Just look at the N1 where they have achieved more than 40% improvement. And so Thunder increases PyTorch large language models training speed by 40%. And they have tested it with Llama 7 billion and few other models. It achieves this by fusing operations such as multiplication and activation, merging torch.nnn function silo using NVFuser. And there are a lot of detail in this GitHub repo. I will drop here in the video's description. Now the way you use it, that you apply Thunder to your PyTorch model by calling thunder.jit function, and I will shortly show you a working demo. This enables enhanced performance for multiple GPU environments using distributed data or distributed data parallel, which is called as also DDP, and also fully sharded data parallel, which is called as FSDP. As we already know that Thunder uses hardware executors, which I explained, and that improves both single and multi-accelerator performance. It integrates seamlessly with PyTorch, standard operations, and AutoGrad. For installation, first install NVFuser with specific pip commands and then install Thunder. Let me show you how. Let me log into my local system and I will be using this Ubuntu here, which has one GPU card, so I'm not going to use multi-accelerator, but the process which I'm going to show will be same for the multi-GPU. First thing we need to do is to install NVFuser plus the relevant version of um, PyTorch. So let me clear my screen, and then all we need to do is to use pip to get these things installed. So let's wait for this to finish. It won't take too long. Once that's done, then we can install the Lightning Thunder. This takes a bit of a time. And this is almost done, I believe. It is also installing NVIDIA stuff. So you can see that my disk space has finished. So let me clear it up and run that command again. So I have cleared the space and let me run this again. This time this should be quick because most of the stuff is already installed. And this is where it failed last time, so it should be good this time. And you can see that it has been installed. Let's now install Thunder. This should be quick, and that is done. Yeah. Now, in order to show you the example, let me launch my Python interpreter and let me import Torch and other stuff. So I have imported Torch. I will also be importing now Thunder. That is done. Let's define a simple function foo, which is just adding two numbers. Let's initialize our Thunder. And this is what I was telling you, that we use thunder.jit function. That is done. Let's define a as sort of a matrix and then also convert it to torch. So both a and b have been initialized with these values. Now both a and b now have been um, converted into 2 by 2 tensor. So b is the name of that 2 into 2 tensor, and torch.full is the function which creates it. And this tensor is initialized with the scalar value of 3 for b and 1 for a. So all elements, for example, in the 2 by 2 tensor b will have the value 3. So that is what is happening here. Okay, so that is done. Now let's get the result with the help of jfoo. That is done. And now let's print the result here. That's it. There you go. So it has converted this PyTorch into the source code compiler to compiler very quickly and very easily. And you can use different hardware executors at once. So this example was for just two tensor, but just imagine millions of them. And this is where it really shines because it makes it very quick and very easy in order to do this sort of compiler to compiler conversion. And also there are a lot of other features which you can find in this repo. For example, Thunder computes its forward and backward passes, and given a Python callable or PyTorch module, Thunder can generate an optimized program that can dispatch computations to optimized kernel that can distribute computation optimally across machines. And there are a lot of other things, for example, multi-level IR to present operation, and lot of extensible set of transformations on the trace such as AutoGrad, DDP, FSTP, VMAP, VJP, and JVP, lot of other things. I will drop the link to this repo in video's description. Let me know what do you think. If you like the content, then please consider subscribing to the channel. If you're already subscribed, then please share it among your network as it helps. Thanks for watching.